a little bit. Every operation always has an inverse to it, right? So the inverse of addition is, and vice versa. Multiplication has division. When you raise, you have rooting, radicals, right? And this is when you have something like this. X to the 3 equals 8, for example. You cube root,
X is 2.
and you do the same thing on both sides. Now, what happens, though, when the variable is the exponent? So when you have 3 to the what, gives you 85. What do? How do you find that x? Logarithms. They came up with the inverse of that.
85 equals x.
Because x is the exponent you're trying to find. Okay? So it's new. Don't make the face like, oh, it's new. It's a new concept. And what you have to get into your head is, how do you find an exponent, which is a variable, logarithm? Somebody came up with this, and we are extremely thankful for them. Back in the day, there were lists of logarithms. So you would have to go to a book to look for the logarithm base 3 of 85.
That's why it's called Logan, the calculator.
Ah, so nowadays we have calculators, and all the lists that used to be in books are now in the calculator. Now, I don't know if this is in the book, but I'm going to give you something specific that I'm pretty sure is not there in there yet. And that is, no, I'm going to give you something later. Just so you know that in the book, in the calculator, you have something that says log, it's logarithm, and it's always base 10. Okay? The one in the calculator is always base 10. And there's one that says natural logarithm, ln, natural logarithm, logaritmo natural. In Latin, which is pretty similar to Spanish, that's why it's ln and not nl. This is the same as natural logarithm in something called base e. My bad. Logarithm is something called base e. E is a number, and it's the letter E in homage to Euler, whose last name started with an E, even though it sounds like an O. It's Euler, this guy.
Euler.
He discovered this number, and it's very common, and it helps you find exponents. So it's a base, and it's 2.71 something. It's an irrational number, just like pi, and it's new. So know that it exists. And right now, all you have to understand.
2.71, 828, 1828.
Yes.
Do we say log or log?
Logarithm. You don't say log because it's not a log. It's not something you chop. It's a logarithm. Okay. Now, let me explain the way a student made me understand, and I thought it was the easiest way ever because I could not remember the order of things. So.
Junior?
No, it was a long time ago. Felipe Sanchez. If I have the b for a base, and this is my exponent, and I'm going to call it x because I'm usually looking for x, right? And this gives me an answer. The inverse of this, or my logarithm, so I can find the x, is logarithm base b, because base and base, of the answer gives me x. This is what you need to have, and this is the base for everything. This is the key, okay? These are inverses of each other. Got it? So how do you use it? You have, for example, they're going to say, write this in logarithmic form. How would you write it? Well, first of all, what's the base?
3.
What?
3.
Oh, yes.
So it's gotta be
Log of 3.
Log of
logarithm base
Base 3. 4.
of,
4, 3,
Equals y.
equals y.
okay.
Wait, how do you do the bases in the calculator?
I'm gonna teach you that later. Right now, just learn how to go from one to another, okay?
That means we don't have to use a calculator for that, right?
No. Okay?
Wait.
All you have to understand is that this is the base, just like with the other one, the big number is the base. So, in both cases, this is the base. You can't do it in the calculator with a base 3, so just so you know. I'll teach you later how to use the calculator to find this out, okay? But know that when you have a base and a number, this represents a number, okay? Just like sine of 30 represents a number, and you put it in the calculator and you get a number, this represents a number as well, okay? Is that clear? So it's a function. Let me keep going. If I have logarithm base b of 9 equals 1/2, and I tell you to solve that, what do? Give somebody else a chance, Simon. I know you understand because I explained it to you yesterday. Nobody?
Oh, yeah. V
Uh-huh.
base. Wait.
To the one.
1
To the
half
one over
equals 9.
Okay, and if I change that,
square root of b equals.
remember that the problem is when the exponent is the thing that I don't know. But if the base is something I don't know,
Square
this
root.
is the same thing as square root of, right?
B
How do you get rid of this? Well, you square both sides. So b equals 81, right?
Yeah.
9 times 9?
Yeah.
Simon, you look incredulous. Is that clear? That's an easy one, right?
Yeah.
How about this one? Logarithm base 3 of 1 over 27 equals m.
It would be 3
Aha.
to the m equals 1 over to the 7.
Okay. So, this you can do the calculator. That's not what we're learning right now. So let's do 3 to the m equals, if this has the same base, this would be 1 over 3 to the what gives you 27?
To the 3.
To the 3, right? So this means that 3 to the m equals 3 to the minus 3, correct?
Yes.
Therefore, m equals
Minus 3.
3. Okay? Is it clear how to switch back and forth? Yeah? And that's it. That's all I can give you for now. Peace.